Okay, imagine this for a second. What if you had just one device, right? And it could listen to aircraft signals,
Hmm.
decode weather satellites, maybe even scan police radio frequencies, all just by changing the software on it.
Yeah, I mean, it sounds like pure sci-fi, doesn't it?
It really does. But it's actually not. This isn't just some lab experiment. We're talking about tech that's deployed right now in defense systems, in avionics, and fascinatingly, even stuff hobbyists are building in their garages.
Exactly. And what we're really talking about here is software-defined radio, SDR.
SDR. Let's dive into that because it feels like a pretty fundamental shift.
Oh, it absolutely is. A total reimagining of how we deal with radio frequencies.
Yeah.
Think about old school radios.
Right, the traditional ones.
Yeah, they relied completely on dedicated hardware bits.
Mhm.
Physical mixers, filters, modulators, each component built for one specific job.
So if you wanted to listen to a different station or use a different mode,
You often had to literally change the physical hardware, swap out parts, reconfigure things. It was, well, rigid, very fixed.
okay, so SDR comes along and just flips that whole idea upside down.
Pretty much. Instead of that fixed hardware calling all the shots, SDR moves almost all that complex radio stuff, the intelligence, directly into software.
How does that work on a practical level? How does it actually do that?
Well, at its core, you've got a pretty flexible front end.
Mm.
Its job is basically just to capture the raw radio frequency signals. Just hoover them up.
Okay, like a wide open ear.
Exactly.
Yeah.
And then it hands off that raw data stream to a computer or some kind of digital processor. And that's where the magic happens.
Then the software.
Right. All the heavy lifting, the filtering, the demodulating, figuring out what the signal actually means is all done computationally by algorithms.
Which means you could listen to FM radio in the morning.
Yep.
Maybe grab weather satellite images at lunch.
Totally possible.
And then, I don't know, analyze drone signals in the evening. All with the same box.
That's the power of it. The versatility is just incredible. But, the really deep insight here isn't just the flexibility.
Oh, what else?
It's the speed of innovation it unlocks. Think about developing a totally new way to communicate or maybe a new countermeasure.
Okay.
With traditional hardware, that could take years. Design, fabricate, test, build. With SDR, you could potentially prototype something in weeks, maybe even days, and then deploy it globally with a software update.
Wow. So it's not just flexible, it's fast. It
Yeah.
fundamentally changes how quickly you can adapt.
Exactly. Which brings us to those critical sectors you mentioned earlier, like defense and avionics.
Right, because adaptability there isn't just nice to have, it's mission critical. Survival sometimes. So how does SDR become a game changer in, say, a military context?
Well, think about a military aircraft on a mission. Things change fast.
Yeah.
New threats pop up. New communication needs arise.
And they don't exactly have time to land and get the engineers to rewire the radios.
Precisely. No luxury for that. With SDR, though, those crucial updates, new frequencies, new waveforms, new encryption, new jamming techniques, can potentially be pushed out remotely via software.
So literally the same physical radio hardware,
Sure.
but suddenly it has brand new capabilities because the software changed.
That's it. We're talking about things like jammers. They can listen to the threats they're facing and adapt their jamming signals on the fly in real time.
Whoa.
Or radars that can change their pulse patterns, their waveforms mid-flight to get a better picture or to avoid being detected or jammed themselves.
That's a level of dynamic response that you just couldn't dream of with fixed hardware, right?
Not even close.
Yeah.
SDR brings flexibility and, crucially, speed that hardware-only systems just cannot match. It's a whole different ballgame.
And what's really exciting, I think, for a lot of people listening is that even though this sounds like super high-end, complex military tech, getting your feet wet with SDR is actually, well, surprisingly accessible. You don't need a nation-state budget.
You absolutely don't. That's one of the coolest parts. You can literally start exploring this world with something like a $30 RTL SDR dongle.
$30?
Yeah.
Seriously?
Yep, a little USB stick. And with that, and some free software, you can start receiving all sorts of signals: air traffic control, NOAA weather satellites, ship positions, pager messages, loads of stuff.
That's amazing. So the barrier to entry is really low.
Extremely low for just listening, yeah. Now, if you want to do more, maybe transmit or work with wider bandwidths or higher frequencies, there are definitely steps up.
Like what? What are the next levels?
Well, you start looking at things like the hackrf or Lime SDR. These offer transmitting capabilities and more flexibility. And then you get into the really serious gear, like the USRP series from Edis Research, which is, professional grade stuff used in labs and industry.
So it scales. You can start small and grow as your interest and maybe your budget allows.
Exactly. It scales beautifully from curious hobbyist right up to cutting-edge research and development.
And it's not just the hardware, right? The software side sounds pretty developed too.
Oh, massively. The software ecosystem is huge and, importantly, very open. You have incredible tools like GNU Radio.
GNU Radio, what's that like?
It's fantastic. It's a visual development environment. You literally drag and drop blocks that represent signal processing functions, filters, demodulators, FFTs, whatever, and connect them together to build your radio application.
Like digital Legos for radio signals?
That's a perfect analogy.
Yeah.
It makes complex signal processing chains much more intuitive to build and understand. Then you've got things like SDR Sharp, often called SDR Shark,
Okay.
which is more like a ready-to-go receiver interface, very popular on Windows. Point, click, tune frequencies, change modes, very user-friendly.
And beyond those?
Oh, there's wide support in programming languages lots of people already know. Python has tons of SDR libraries. MATLAB has toolboxes.
Yeah.
You can even find SDR apps for Android phones now.
Wow. So once you start looking, SDR capability is kind of everywhere.
It really is becoming ubiquitous.
Okay, let's make this even more concrete. Can you walk us through a simple real-world example, something someone could maybe actually try?
Sure. A classic starter project is decoding ADS-B signals from aircraft.
ADS-B, that's the system planes use to broadcast their position.
Exactly. Automatic dependent surveillance broadcast. Planes are constantly transmitting information about themselves, who they are, where they are, their altitude, speed, heading.
And normally, only air traffic control, or maybe like Flight Radar 24, sees that data.
Pretty much. Or other aircraft, of course.
Yeah.
But with the simple SDR setup, that cheap RTL SDR dongle we mentioned, a small antenna and a laptop running the right software,
Yeah.
you can sit there and watch in real time planes flying hundreds of miles away showing up on your screen. You decode their exact position, altitude, speed. It's fascinating.
Yes, with that little USB stick and a laptop, that's incredible. You're pulling flight data right out of the air.
Right out of the air. And then, pause and think about scaling that basic principle up.
What do you mean?
Well, that same fundamental idea, receive RF, process it in software, is the foundation for those incredibly complex systems we talked about. Sophisticated airborne radar systems, secure frequency-hopping military communication links, systems for managing the entire electromagnetic environment on a battlefield.
It all comes back to that core idea of software defining the radio's function.
Precisely. It's not just about fixed circuits anymore. It's about the code.
So yeah, while it's definitely a fantastic playground for hobbyists and experimenters, SDR is clearly way more than just a cool toy.
Oh, absolutely.
It feels like a genuine revolution in how we interact with, well, the entire RF world, moving from that fixed, hardware-centric past into this much more dynamic, software-driven future.
That sums it up perfectly. It fundamentally changes the game by moving the intelligence, the capability, from hardware that's difficult and slow to change into software that's flexible, adaptable, and fast.
We're capturing, processing, understanding those invisible waves all around us in a completely new way.
And honestly, it feels like we're still just getting started with what's possible.
So just to wrap up then, the core idea, software-defined radio shifts the heavy lifting from fixed hardware to adaptable software, revolutionizing how we work with radio frequencies.
Couldn't have said it better myself.
And maybe a final thought for everyone listening. If you're at all curious about this hidden world of radio waves, maybe you're into aviation or defense tech, or you just, love tinkering with futuristic stuff. That laptop sitting in front of you, it's not just a computer anymore. With a little bit of SDR gear, it actually transforms into this incredibly versatile multi-tool for exploring the radio spectrum.
A window into the invisible.
Yeah. The next frontier isn't necessarily out there in some high-tech lab. It could genuinely be you, right there, building your very first software-defined radio receiver and seeing what you can discover.